Hey everyone, this is a new 3-inch drone that I just built, and I am super excited about it because this is my first chance to try the Shark Byte digital FPV system. So today I want to show you how I built this drone. There were lots of interesting choices along the way that led me to this final design, and I'm really happy with how it turned out. It's light, it's quiet, and it's super clean. So I want to show you this on the bench, and then we'll come out here and I'm going to fly this as fast and as hard as I possibly can right here in my backyard. I want to see for myself if Shark Byte can give me an FPV experience that's better than analog, but still be light enough and responsive enough for me to pull off the crazy moves that I like to do in my backyard. I'll even try diving these giant Douglas firs behind my house. That is something I normally only do with ultralight 1S drones, but if this one can do it and give me a better FPV experience, then for me personally, I think my money on Shark Byte will have been well spent. I have the DJI system too, and it's great in a lot of ways. I enjoy flying it on some of my drones, but both systems have strengths and weaknesses. Shark Byte brings some different strengths to the table, so that's why I'm excited to try it out. So let's go back to the bench. I'll show you how I built this drone, and then we're gonna fly it, and I'll probably wrap up with some of my initial impressions of using the system. Okay, this is my first time trying out the Shark Byte system, and I'm pretty excited about this, but before I can try it out, I've got to build something with it, so let's get started. You can see I've got the VTX right here. This is the TX5S.1 video transmitter. It's 200 milliwatt, has a little UFL connector, and it's on a single board. And the fact that this is a single board is super exciting to me. I build a lot of micro drones, so having something that's really easy to mount is going to be pretty sweet. And this mounting pattern is just like a Whoop all-in-one flight controller. So it's also going to save weight. Here it is, 5.6 grams for that. And just for comparison, here is a naked DJI air unit or Vista air unit, about 9.7 grams. For the camera, I've got this Run Cam, and it's 720p, and it weighs 4.2 grams. For my first Shark Byte build, I've decided to go with a 2S Baby Tooth as the platform, and this is one of my previous Baby Tooth builds. You might have seen this on my channel. I nicknamed it the DigiTooth because it's got the Caddx Vista air unit. So this is DJI digital FPV in a lightweight 2S drone, and this was pretty cool, but it was like 29 grams, and it had the Nebula Nano camera, which is not the best camera. I meant to upgrade this to the Nebula Pro or to a full-size DJI unit. I just haven't done that yet, but I'm excited about the Shark Byte one. I'm hoping that this Shark Byte build can be significantly lighter than what we had on here, and we'll see how that works out. And then this is the Happy Model Crux 3. This is a bind and fly drone, and I made a video about this one recently as well, and it's pretty close to the specs that I want. So it would actually be, I think, a really easy build to stack this on top of the flight controller, lift up the canopy a little bit. It might need longer screws. This camera, the Ant camera, is actually the same mounting pattern as this one. So if the lens fits through there, then this could actually be a really easy conversion. I'm not sure if the lens fits in there. I haven't actually done that yet. And that's not where I'm going to start. I'm going to start by stripping this down all the way for parts, just so I have all of these parts available for my own build, and then I'm going to build it up from scratch. This is just something I enjoy doing, I like to build, and I'm very particular about certain things, especially weight, so we'll make those choices one at a time as we build it back up. Okay, these are all of the components from that Crux 3 build. I stripped it down completely. As you can see, all the little nuts and bolts are in here. Here's the frame, these 1202.5 motors. We've got the Crazy Bee 2S flight controller with the Crossfire Nano receiver on there and the stock wires. Probably make some changes to that too. But the way that is right now, it's about 8.3, 8.4 grams. Mini Mortal T Crossfire antenna. These are the bands that we're holding on the batteries. We can probably do better than that. And then this is all of the mounting hardware. There we go. 4.2 grams. That stuff really adds up. Now, most Whoop flight controllers only have 5 amp ESCs, and this Crazy Bee board is no exception. So a lot of people ask me, is that really enough? Is it enough for something like a Baby Tooth or this Crux 3? Obviously, it's enough to fly with, but is it enough for safety, or are you going to worry about burning an ESC? And that is a great question because plenty of people have burned ESCs on this board and on other boards that are like it. But I've had pretty good luck for the most part, and I've got this board and I've got these components, so I'm going to keep trusting to my luck, but it's not a guarantee. The first change I'm going to make to this board is going to be to remove this analog FPV antenna. Again, this board has a built-in analog VTX, but we don't need that feature anymore because we're going digital. And there we go. Goodbye, FPV antenna. So the first thing that's blocking us is this connector right here. That was the connector for the analog FPV camera, and so I'm actually going to take that off. I'm going to end up taking these plugs off as well because once this is off, the board will be able to go lower, but then these motor plugs will start sticking down where the battery goes. So I've decided I'm actually going to direct solder each of these motors. And that'll also save a little bit of weight, but my main reason right now is to get this build as compact as possible. It's going to be a little bit tricky to do this on camera, but we'll see if we can make this work. There we go, no more plugs, and you can see how thin it is. Now it's time to get some motors on there, and they came with these screws, 4 per motor, so there were 16 of them total, 2.6 grams. But I've got some of these titanium M2x4 screws, so I'm going to use these, and I think 2 per motor is going to be enough. So a set of the titanium screws is going to be 0.6. And there's a problem. I should have anticipated this. These screws are too short for this frame. The Crux 3 has a 2.5 millimeter thick frame, and these screws do fit through, but that's not enough threads to hold the motor, so this combination isn't going to work. Okay, so change of plan. I've decided to go with a baby tooth frame. This is how the design process goes. Sometimes I don't know how these builds are going to turn out until I get into it. So I've got the 1.5 millimeter thick version of the baby tooth frame here, and I use this for really light 1S builds, and it's great. And it's super light. So this is like 1.7 grams lighter than that Crux 3 frame. And then this is the 2 millimeter version of the baby tooth, and it is about the same weight as that Crux frame. So I'm going to go with the 2 millimeter frame for now. I'm kind of curious to try this one. I might try it later, but I think the 2 millimeter is going to be better, both for durability and in terms of flex. If there's too much flex, then you get resonance in the frame, and that's really hard to deal with the tune. But I think this will do well. This is 2 millimeters thick, so it's thinner than that Crux 3 frame, but I can tell just by holding it that this is considerably stronger. It's considerably stiffer. Now, the only reason I didn't go with this frame right off the bat is that it's got 3 holes here for the screws, and there's nowhere for the USB to go. And I'm going to need a downward facing USB. It can't be upward facing like it would normally be on a baby tooth because we're going to have that board above it. So what I'm going to do is I'm going to cut off one of these tabs so that the USB can post down, and then we'll just have 3 screws for holding on the canopy. But that'll be enough, and that is in fact what I did on this other DigiTooth. This is the underside of the flight controller, and if you look right here, there are tiny, tiny little pads for a second UART. That's R2 and T2, and I'm going to need those, so I'm going to solder 2 extra wires onto them now. It'll be more convenient now instead of when I put it on the frame with the motors. And this is going to run MSP to the Fat Shark video transmitter. I wish these pads weren't so tiny, but at least they exist, which is not always the case with these Whoop-style flight controllers. You know, now that I've got it assembled this way, I'm actually starting to second guess my plan. I was so sure that I wanted this on top because I usually put the flight controller on the bottom, that way the motor wires don't have to come up like this. But there's actually a few reasons I've thought of why it might be better to have this on the bottom. And if we put the flight controller on the top, we could actually flip it upside down and have that upward facing USB, and then this would go underneath. Let me just try that out and see how well it fits. Oh yeah, I'm glad I tried it because I'm liking this a whole lot better in this configuration with the VTX on the bottom. And there's a couple of reasons. First of all, the VTX is wider. So I kind of just visually, I think it looks nicer to go from a wide base to a narrow top instead of having the VTX kind of overhang the flight controller. That's kind of a cosmetic thing, but there's some functional things as well. The VTX has these connector plugs on it, and this one in particular is pretty large. So if that's on the top, it could get in the way of a canopy. That's one reason. Another reason is that with the board oriented this way, these signal wires have a really short path to go, straight down to here where I'm going to solder them on. And another reason is this capacitor. Companies that make bind and fly drones often put the capacitor out here on the power lead, and that's just not a very good place for it. For one thing, it makes the wire inflexible at this point, so that could get in the way. But also, you're supposed to put the capacitor as close to the source of the electrical noise as possible for the best filtering, or at least that's what I'm told. So it would be better to have the capacitor right here connected directly to the VBAT pads. I did not resolder these motor wires, I just flipped the whole thing over. So that has the downside that these wires are going to have to cross each other. That might not look quite as clean, but it's fine. It'll look fine once I tidy it up. And having them wired to the bottom side of the flight controller actually is going to make this build look super clean when we're done. There we go. That UFL shouldn't be going anywhere. The grommets on the flight controller provide almost enough spacing between the two boards. I just need a tiny bit more spacing. And so for that, I've got a few more grommets. Just take them like this and cut them in half. That's what I've got here. So let me put those on. Now to finally hook up this VTX. We've got two wires here. The yellow one is from R2. So that's a receive pad, and it's going to have to go to the transmit pad on the VTX, which is this far left one. Green is T2, and that's going to go to the receive pad next to it. And then I'm going to have to add two more wires for power. Okay, so let's get this camera mounted on here. Luckily, it is a standard size. We call these nano cameras. It's 14 by 14 millimeters on the back plate. And there are several mounting options. There's canopies that you could buy or things that you could print off Thingiverse that are designed to hold this size camera and mount onto a Whoop style flight controller. But I've made my own job a little bit more difficult here by going down to 3 screws. That was kind of my fault. But this upward facing USB is also going to get in the way of a lot of canopies. For example, on my DJI Digitooth, I use this Racer X FPV canopy. It's a great canopy, but the back here would hit the USB on this frame, so it would have to be modified if I wanted to mount it like that. So I'm not going to use this canopy or anything that has a back part like this. The most obvious choice is to mount it just like a regular baby tooth. The baby tooth frame designed by Kebab FPV was originally intended to be used with this B-Brain V2 canopy from Newbie Drone, and that works really well. You see that in builds like that. You may have seen my video about this little guy, the NanoHawk conversion. I did the same thing. Again, upward facing USB works fine with this canopy. Luckily, I was able to find an STL file on Thingiverse that kind of imitates the B-Brain canopy, and so I loaded that into Tinkercad and started messing with it. I ended up using just the feet from that model, and then the camera housing I completely rebuilt so that I could adjust all of the dimensions and make that fit perfectly, and also adjust the angle and exactly how it fits onto the legs. So here's what it looks like in Tinkercad. I'm pretty happy with it. I think this will work pretty well. So let's get this printed and see how well it fits. And here it is off the printer. I printed it in black TPU, 100% infill. You can see the opening for the lens is significantly larger, and these blades to protect the lens are significantly longer because it's a pretty long lens on that RunCam camera. The weight's going to go up a little bit compared to the original though. It's almost 2 grams, 1.9 grams, and the B-Brain V2, 1.25. It should fit right in like this. It might be a little bit of a tight fit just to get past the first part. There we go. And then it just goes in right like that. I've got the ribbon cable pointing down, and that's technically upside down for this camera, but that's no problem because you can flip it vertical flip with this little remote. So that's fine, and this cable I think can just kind of tuck like that. Yeah, that should work pretty well. I might continue to make some tweaks, but this should be good enough certainly for us to get it in the air and start getting some experience. I'll put this STL file on Thingiverse as well, of course, and I can make different angles. Let me know if there's different variations you'd like to see. It wouldn't have to be just for this camera, of course. This would let you mount any 14 by 14 camera, especially ones that have a larger lens. And here is the finished build. I might make a few tweaks later on, but I am really happy with how this has turned out so far. To get it cleaned up, I just added some cloth tape and straightened out these wires. I added some cloth tape to hold on the Crossfire antenna. The Crossfire receiver has some Kapton tape that just insulates it inside of there. And this is the FPV antenna back here. It's a True RC Singularity, which is a very high quality antenna. I didn't want to skimp on antenna quality because having good video is kind of the point of going digital. But unfortunately, this isn't really an ideal placement for it. In a crash, it could get knocked up into the props, and the orientation might be a little bit better if it was attached to the back of the canopy, but that would require some changes to this canopy, so I might do that later. For now, I've just got it zip tied onto the arm, and there's a second zip tie on the far side of it that helps to maintain the kink so that it holds its orientation like this. On the bottom, you can see I removed the extra capacitor from the power lead and I shortened the wires. It's attached to the arm with a zip tie so that it can't yank on the flight controller, and the battery's just going to plug in like this. The battery itself is held on with a Velcro cable tie, and I really like these cable ties. They're pretty light, and they're a lot stronger than you might think. And to fit it on the frame, I just had to put a circular hole in the cable tie right there. I didn't need one in the back because I had cut away that post, but if there was a post there, I could do the same thing. And once these strap on nice and tight, it'll be pretty secure. 50.5 grams, plus the weight of a 2S battery. I can probably make some tweaks later to get the weight under 50, but this is what I'm going to fly it with, and I am super excited about this. The performance of this thing should be pretty sweet at that weight.
Okay, this thing is awesome. I am so glad that I built this, and I'm so glad that I decided to try out the Shark Byte system because I've really been enjoying it so far. It's not perfect. There are rough edges like blocky artifacts that show up on the screen, but in spite of that, I feel like this might be the best FPV experience that I've had here flying in my backyard. Because when I fly fast in tight spaces, the weight and the latency are both really important to me. I have DJI quads that I fly out here too, but I do notice the latency on those. It's not bad, but it is there. And more importantly, the latency on DJI changes dynamically. So it feels like it speeds up or slows down. I know a lot of people don't even notice that. That's great for you. I unfortunately am pretty sensitive to that. I really appreciate the rock solid timing of analog. So I usually fly analog in these tight spaces in my backyard, but I feel like the Shark Byte system gives me that same low latency, same rock solid frame rate. It never misses a beat. There may be breakup on the screen instead of the static that you would see in analog, but the timing is just really good, and I've really been enjoying it. And compared to analog, I would say it definitely has more detail than I'm used to seeing in analog. I don't know if you're going to be able to tell that on YouTube because the compression in the goggles and the compression on YouTube really kind of destroys the image. I think it looks better in the goggles, especially while it's moving and you see how fluid the motion is. I think that's better than what I've seen on YouTube. So try to keep that in mind. These are just my opinions. Of course, it's based on what I want out of FPV, and that is very subjective. So no doubt other people will come to different conclusions about the trade-offs between price and weight and latency and image quality. So I'd love to hear what you think down in the comment section below. Have you tried Shark Byte? Have you tried DJI? Have you tried analog? What systems would you rather use in different contexts? Because there's definitely different contexts to consider. And I have not tried Shark Byte in all of those contexts. I haven't tried pushing the range, for example. I've not tried pushing the penetration. I don't know how well it will work in those kind of contexts. DJI works really well for some of those things. So I expect that I will continue to fly DJI as well, especially on larger drones. Like flying 5-inch out in the open, I love the picture of DJI, and the latency in that context doesn't bother me as much. So I'll definitely continue to do that. But when I fly in these tighter spaces at higher speeds, I'm really enjoying the feel and just what it feels like to me subjectively to fly with the Shark Byte system. And so I'm excited about the possibilities for that. I think it'll be great for racing too. We haven't had any races in a long time because of COVID, but when that starts up, I definitely might try Shark Byte for that as well. Well, this has been a very fun project, and I'm happy with how it's turned out so far. This thing is light, it's quiet, it's fast, it's fun. I feel like I could fly this just about anywhere without bothering people too much, and that's one of the things that I love about micro drones, and so I'm looking forward to flying this some more, and it's proven to be pretty durable too. If you want to see that, check out some crash footage. I wasn't happy with how this flew initially, so I ended up doing a custom tune. It involves settings on both the ESCs and the flight controller. So if you want to see about that, look down in the video description. I'll put that information down there, along with all of the links, links to the products and parts that I've used, and links to related videos and to the STL files for this canopy. So if you want to see any of that kind of stuff, check down in the video description. I'll probably put some extra info down there too about flight times and batteries and props, just to keep this video a little bit shorter. I might write some of that down in the description below. So check that out if you're interested. I hope you've enjoyed this video. Thanks for watching to the end. If you enjoy this kind of stuff and you want to see more content from my channel, of course, you know what you can do. And so I appreciate that. Thanks for watching, and I'll see you next time. Well, I got some bad news. After I had filmed everything for this video and before I had a chance to edit it all together and get it out the door, I ended up flying this some more in my backyard because I love this thing, but I ended up burning one of the ESCs on the back. You can see if I try to arm it, this back right ESC is dead on the 5 amp board. So Apparently that 5 amp board was not up to the challenge. I'll be replacing it right away. I'll probably use a 12 amp board instead.